Hello, everybody. Today we're going to start on one of my favorite topics, factoring. And we're going to focus on how do we factor the simple case for quadratics today. Okay, so to start, let's think about the things that we already know. We know how to FOIL. If we have two binomials, x plus 2 and x plus 3, we know how to distribute the x plus 2 into the x plus 3 to end up here at x squared plus 5x plus 6. But with factoring, we're wondering, how do we go backwards? How do we start with something like this and end up here? Well, that's exactly what we're going to talk about today. And the simple case, as referred to up here, the simple case is whenever you just have a 1x squared out in the front. So that's whenever a equals 1. That's the simple case. And I'd like us to kind of look at this, x squared plus 5x plus 6, and then this x plus 2, x plus 3. Did you notice that 2 times 3 is 6, and 2 plus 3 is 5? And that comes from the FOILing. You see the 2 plus 3 right here, and then this was 2 times 3. All right, so let's just jump right into it. All right, so to factor, for the simple case only, okay, so it's really important. This is only whenever a equals 1. We have to find two numbers that will multiply to equal c and will add to equal b, just like we saw with that 2 and 3 multiplying to 6 and adding to 5. All right, so let's look at an example. Here we have x squared plus 5x plus 4. The first thing that I want to do is think of two numbers that multiply to equal c. So here's c, 4. So in my head I'm thinking, all right, I know 2 times 2 equals 4, but does 2 plus 2 equal 5? No. All right, 1 times 4 equals 4, and 1 plus 4 equals 5. So the numbers must be 1 and 4. So whenever I factor this, this would be x plus 1 times x plus 4. And these are the factors. Now, of course, I could check myself. I could FOIL this back out and get x squared plus x plus 4x plus 4. And once we combine like terms, you'd see that this would be x squared plus 5x plus 4. You have to be real careful to notice your positive and negative signs. Here, I need two numbers that multiply to 20 and add to negative 9. So if the two numbers are going to multiply to a positive but add to a negative, what do we know about those two numbers? Think about that for a second. We know that a positive times a positive equals a positive, and I need to get a positive here. But a positive plus a positive wouldn't be a negative. So I also know that a negative times a negative will give me a positive, and a negative plus a negative is going to give me that negative term I need in the middle. So my factors of 20, let's see, there's no way that 1 and 20 could add to 9. 2 and 10, those won't add to 9. Let's see, 4 and 5. There's probably a way I can make those be 9. So my factors here would be x minus 4 times x minus 5. Now why do they both have to be negative? Because we have negative 4 plus negative 5 is negative 9, whereas negative 4 times negative 5 is positive 20. All right, try to use those rules to factor these two problems. I really want you to pause the video and try these on your own, and then we'll come back together. Did you pause the video? Well, all right, here we go. So here we have x squared minus 13x plus 22. You should have ended up here at x minus 11 times x minus 2. We knew that both numbers needed to be negative because they multiply to a positive yet add to a negative number. Now over here we have a case that we haven't seen before. For two numbers to multiply to a negative, only one of the numbers can be negative. And since they add to a positive, we know that the smaller number needs to be negative. So let me show you what I'm talking about. With factors of 40, we have 1 and 40. We know we can't get 3 out of that. 2 and 20, no. 4 and 10, can't make that into a 3. 8 and 5. Well, I know that 8 minus 5 equals 3. So my factors are going to be x plus 8 times x minus 5. So let's check ourselves. 8 times negative 5 equals negative 40, and 8 plus negative 5 is positive 3. So these are the factors. What if we can't factor the trinomial, right? Like, what if we have x squared plus 2x plus 4? Are there any two numbers that multiply to 4 and add to 2? See, well, the only factors of 4 are 1 and 4, 2 and 2. There's nothing that adds to 2. So in this case, we say it cannot be factored. All right, I'm going to show you a few special patterns. These patterns often show up, so memorizing them could be very beneficial to you. The very first one is one of my favorites. It's the difference of two squares. Basically, whenever you see something of the form a squared minus b squared, this factors down to a plus b times a minus b. I know what you're thinking. Those are letters. So let's try to look at an actual example of this. If I had x squared minus 9, well, the x squared is pretty obvious, right? A squared, x squared. This factors down to x times x. So here I've got this situation going. Now, over here, this minus 9, 9 is just 3 squared. So this factors down to x plus 3 times x minus 3. Now, you might want to say, okay, why does this work? If you FOIL this out, you'd have x squared plus 3x, and then you'd have a minus 3x, and then 3 times negative 3 is negative 9. So whenever you have 1 plus and 1 minus, these two middle terms cancel each other out. And that's why we have just the x squared minus 9. So here, you try it. If you had x squared minus 25, what would that factor down to? Hopefully you're thinking, okay, that's x plus 5 times x minus 5. The next pattern isn't as easy to see, so a lot of times you can just go ahead and factor your normal way. But just in case, this is called perfect square trinomials. And for this we have two cases. If you see something of the form a squared plus 2ab plus b squared, this factors down to just a plus b times a plus b. Or we can write this a little bit shorter as a plus b squared. Or if you have a squared minus 2ab plus b squared, this factors down to a minus b times a minus b, or a minus b squared. So like I said, this is a little bit harder to see, so I'm going to show you just a normal example, like what we've been looking at, and then I'll show you how it relates back. So let's factor x squared minus 6x plus 9. So if we're doing this the way that we've been doing it, we know that 3 times 3 equals 9, and then that they both have to be negative because we need them to add to negative 6. So this would be x minus 3 times x minus 3. Or I could just say x minus 3 squared. So here, this is my a minus b squared. Well, if this is a minus b squared, that would mean that this x is representing the a and the negative 3 is representing the b. So let's try to plug these things back in and see if we get this whole thing. Let's see. That'd be x squared for the a squared. Negative 3 squared is the positive 9. And then here we have negative 2ab. Well, what's negative 2 times x times negative 3? Well, that's negative 6x. So this is a perfect square trinomial. Go ahead and give it a try here with the x squared plus 12x plus 36. Hopefully you can see that this is x plus 6 squared, because 2 times 6 is 12 times x is 12x. And we have an x squared and 6 squared. All right, so far we've only been factoring expressions. Expressions don't have an equal sign. If we do have an equal sign, it's an equation and we can solve it. All right? Well, whenever we solve an equation, what do we call those answers? We call them solutions. But with quadratics, we have a lot of names for them. They're also called roots. Okay? You'll hear that word a lot. You'll also hear zeros. And basically what they all are, and this is the last name, they are x-intercepts. So that's a huge concept, this x-intercepts. The solutions to a quadratic are where that quadratic hits the x-axis. And we'll study that for the next while. All right, to solve, you just set each factor equal to 0 and then solve. So let's say we had x plus 2, so I'm jumping a few steps, and x minus 3 equal to 0. To solve this, I would set x plus 2 equal to 0 and x minus 3 equal to 0 and solve. So if x plus 2 equals 0, then x must equal negative 2. Right? And I got that from subtracting 2 from both sides. Or if I add 3 to both sides in this other one, I get x equals 3. So the solutions to this right here, x plus 2 times x minus 3, would be x equals negative 2 or 3. These are the roots. These are the zeros. These are the x-intercepts. So I know that this hits the x-axis at negative 2 and 3. So let's try that. And so here we have x squared plus 7x equals negative 10. So yeah, this looks a lot different than what we've seen before. The very first step is to set it all equal to 0. So I'm going to have to add 10 to both sides. Now I've got my whole quadratic by itself. X squared plus 7x plus 10 equals 0. All right, now I'm going to factor this side. What two numbers multiply to 10 and add to 7? Yeah, 5 and 2. I just had a Dora moment with you guys. X plus 5 times x plus 2 equals 0. And let's check ourselves real quick. 5 times 2 equals 10. 5 plus 2 equals 7. Now to solve, let's set each of these factors equal to 0 and solve for x. So subtract 5, x equals negative 5, x equals negative 2. The solutions are x equals negative 2 and negative 5. Right here. Now you guys give it a try, and this will be the last example of our notes. X squared plus x equals 30. All right, so after moving the 30 over to the other side of the equation, we can factor and see it's x plus 6 times x minus 5. Whenever we solve, we set each of those factors equal to 0, so x equals negative 6 and x equals 5. All right, and that's all for factoring the simple case.